Hi everybody, today we're going to talk about z-scores and percentiles, and we'll be using Excel to help us answer questions. In statistics, the percentile is the score for which a specific percent of the data is below the given percent. For example, in a standard normal distribution, we might want to know the z-score for the 84th percentile. From the 68, 95, 99.7 rule, we know that 34% is between the mean and one standard deviation to the right of the mean. We also know that 50% is to the left of the mean. When we add 34% and 50%, we get 84%, which shows us that our z-score is equal to 1. What if we wanted to know the z-score for the 98th percentile? We are going to use Excel to help us find the answer. We use a command called norm.s.inv because we're using a standard normal distribution. So in Excel, I'll type in equals, and as I start typing norm, I can see I have a lot of choices, and I'm going to click on norm.s.inv. It says we just need to enter the probability, and our probability was 98%. We want the 98th percentile, which means 98% is to the left of this z-score. So I type 0.98. It gives us a number of 2.0537 for 8911. We could make that 2.0537. Let's take a look at some applications. The number of calories burned in a 30-minute spin class was recorded using a fitness watch. The data found an average of 381 calories with a standard deviation of 27 calories. Let's find the number of calories that correspond to the 98th percentile. In this situation, the mean is not 0 and the standard deviation is not 1. Because we have a mean of 381 and a standard deviation of 27, we don't get to use the standard normal distribution. The command we're going to use in this situation is norm.inv. We need to put in the probability we want, the mean, and the standard deviation for our problem. I'll type in equals, start typing norm, you'll see the .inv. It asks for the probability, we put in 0.98. It asks for the mean, that was 381. Our standard deviation is 27, and it gives us a value of 436.45. In this case, this is not z, this is an x value. Z is for a standard normal distribution. We usually call values x when they're for a normal distribution. What does this tell us? This says 98% of the class burned less than 436.45 calories. So let's go back to our situation and answer another problem. Let's find the interval of calories that 80% of spin class participants should expect to burn in a 30-minute class. We'll start by looking at a normal distribution. I've marked off 40% on the right of the mean and 40% on the left of the mean. That makes up our 80%. So let's stop and ask ourselves how much is remaining of our graph. Since the entire graph is 100% and we've already accounted for 80%, we have 100 minus 80, which is 20%. We need to split that into the right and to the left. So that means we have 10% on the right, we have 10% on the left. We need to find two x values, one on the left, one on the right. Let's start with the one on the left. That'll be an easy calculation. In Excel, we go back to our norm.inv, and we want to know the x value for 10%, so we put in 0.10. We return to our mean of 381, our standard deviation of 27, and it says our value is 346.398. We'll call that 346.4. Now that we have our number for our left boundary, let's look at the number for the right boundary. When we go over to the right, we can see that 40%, 40%, and 10% is to the left. That's a total of 90%. So the number we need to look up corresponds to the 90th percentile of our curve. We'll type in equals, norm, and we're going to .inv. This time we put in 0.90 for the 90th percentile, 381 for our mean, 27 for our standard deviation, and we get 415.6. This says that 80% of participants should expect to burn between 346.4 and 415.6 in this 30-minute spin class. Let's try a different situation. An entrance exam for an elite training school has an average of 127 and a standard deviation of 11. Let's find the score needed to be in the top 5%. The top 5% is far on the right, which we would call the right tail. When we're looking at norm.inv, it's always giving us the area to the left. So we need to find the x value that has 95% of the area to the left. In Excel, I type equals, I'm typing norm, grabbing .inv. Our percentile we're putting in is 0.95. Our mean was 127. Our standard deviation was 11. This says the score needed to be in the top 5% would be 145 or higher. Let's try one more example. Our particular used car has an average resale value of $14,500 with a standard deviation of $825. Find the value corresponding to the 25th percentile for the car's resale value. Remember, the 25th percentile is like our first quartile, so if you had a problem about quartiles, you would want to go back and think about what percent does that represent. Hopefully by now you're thinking, let's go to Excel, type equals, type norm.inv. In our parenthesis, we put 0.25 to say it's the 25th percentile. 14,500 is our mean, and notice we do not put in commas because that tells Excel something different, so no commas in your thousands place when you're putting in these numbers, and then 825 for our standard deviation. This returns a value of 13,943.55. Remember, this would be the first quartile value or the 25th percentile value of the cars being resold.